For centuries, we've been circling around this one question. It's a question that sits right at the heart of science, of philosophy, really, of everything. And today, we're going to dive into a pretty radical answer to that ancient mystery.
Yeah, what's it all made of? I mean, really? When you strip away all the particles, the forces, all the fancy equations, what's the fundamental stuff of our universe? Let's explore a fascinating and pretty wild answer to that exact question. So, to get to that radical answer, first we have to get a handle on the current debate. It's kind of like a detective story, with two main suspects for what reality is really made of.
Okay, so on one side, you've got the classic view, physical reductionism. This is the idea you probably learned in school that everything, from a star to a thought in your head, is just matter and energy. But there's a new contender in town, coming from fields like complexity theory, and it's called informational reductionism. This camp says, nope, the real foundation isn't matter, it's information itself.
Now here's where it gets really interesting. There's a big, glaring problem with this new information is everything theory. Just think about it for a second. A book is just paper and ink, right? It's meaningless until someone actually reads it. Well, it's the same idea here. Information, like the code in our DNA, doesn't do anything without a physical system, without matter, to read it and carry out the instructions. Mathematician David Berlinski put his finger on this problem perfectly with this quote. So you've got this physical thing, a DNA molecule, on one side of the equation. And on the other side? Well, apparently everything. I mean, how can one little molecule account for, well, life itself? The two sides of that equation just don't seem to balance out.
And here's the real twist in all of this. This super modern, cutting-edge scientific debate, it's not new at all. In fact, it's just the 21st century version of a philosophical headache that's been around for hundreds of years.
So way back when, the big debate was mind versus matter. You had the abstract world of thoughts and ideas on one side and the physical world of stuff on the other. And today, the debate is information versus matter. It's the exact same fundamental divide. It's just dressed up in new scientific clothes.
This gap, this stubborn divide between the two worlds, actually has a name. It's called the explanatory gap. Think of it like a huge chasm between the world of abstract information and the world of physical stuff. And for centuries, we have been trying to figure out how to build a bridge to cross it.
So what would a bridge like that even look like? The source material we're looking at today suggests that before we can even start building, we need a whole new kind of analytical tool, a new way of thinking about the problem. Now, to build this bridge, the author proposes using a framework with a very loaded name, intelligent design theory. But it is absolutely crucial to understand how they're defining it here. They are not talking about a conclusion about a cosmic designer, not at all. They're using the term to describe a purely mathematical method, a way to use probability and complexity to analyze nature, hoping to find a model that can finally unite the informational and the physical. So this is the billion-dollar question, right? What kind of idea, what kind of massive conceptual shift is powerful enough to finally dissolve this ancient divide between the abstract and the concrete? What could possibly bridge that explanatory gap?
And this brings us to the absolute core of the argument we're exploring today. After all this time, the author claims the answer has been hiding in plain sight the whole time.
The answer is language. Not as a metaphor, not as some neat analogy, but as the literal, fundamental structure of reality itself.
Whoa, okay, so what does that even mean? Well, the argument isn't that we use language to describe the universe, it's that the universe is a language. The idea is that language is the most fundamental mathematical structure there is, even more basic than numbers or geometry. And in this view, everything, scientific theories, our own thoughts, how we see the world, it's all just different forms of this one underlying language.
Okay, so if reality is a language, that's a huge idea to wrap your head around. But how would that actually work? What are the grammar and the syntax of the universe?
The author breaks it down like this. First, what we call the laws of nature aren't really laws. They're just incredibly stable, repetitive patterns. Second, because these patterns happen everywhere, they act like a set of distributed instructions that everything has to follow. And third, when you put all those instructions together, they form what the author calls a control language for reality. And that right there is the key that unlocks the whole puzzle. In this model, the language isn't written on reality, like software on a computer. The language is reality. Suddenly, information and matter aren't two separate things fighting each other. They're just two sides of the same coin, two inseparable parts of one linguistic structure. And that old explanatory gap? It's finally closed.
So we're left with this, a thought that completely reframes our place in the cosmos. If the universe really is a language, a self-organizing, self-writing story, then what part do we play in it? Are we just characters reading the lines? Or are we, somehow, part of the authorship? That's a profound question to chew on.